All right, there we go. We're recording. Okay, so to get started, we're having a look at something called indices. Also, yeah? It was there a second ago, wasn't it? I didn't imagine that. Come on. Oh. There we go. Okay, as I was saying, so we're looking at indices, or another word for indices, does anybody know? Oh, okay, that's just a singular. Now give me something interesting. Another word for indices? No, not that. Nice try though. No? Power, yeah. Yeah? Or yes, Ishpreet, if you want index. I'll put it underneath index. Or in Arabic, aus. Yeah, isn't it? Power, yeah. Yeah, but we'll stick to English so everyone else can understand. Okay, so we'll have a look at some basic rules first. We kind of touched on some of these already. I think a lot of them you would know. So the first rule of our powers here, if you have x, well, I'm sure everyone knows this, x power n and then x power m, then in total you get x power n plus m, like that. Okay, so that is rule 1. First rule. Okay. And we'll do the proofs, because the proofs are quite short, quite straightforward. It'll be good practice. So the proof here, xn times xm, that would be x n times, wouldn't it? And then this one here, how many? M times. So this is like saying we have n plus m x's, don't we? We have n of them in the first multiplication, m of them in the second. So in total, it's n plus m. It's hardly a proof. It's pretty straightforward, you know. You have n of them here and m of them here, then in total you have n plus m of them. Okay, if you can write that down, that's our first rule. Yeah. I think it's good practice to have the proof in your notes, okay? It's just good algebra. So if you can have a copy of the proof in your notes as well, that'd be great. You got this, Alex? The proof as well, yeah? So some of you could probably guess what the second rule I'll do is. What might that be? Yeah, go on, have a guess. What could it be? Divide, yeah. So if I scroll down, the second rule, xn over xm, that's equal to x n minus m. And the proof, so xn over xm, on the top you'll have n of them, and then on the bottom you'll have m of them. I should put the m outside the dots. And what happens here? You can cancel, can't you? So you can cancel 1 and 1, and then 2 and 2, and so on. So in total you're left with n minus m left, because for every 1 down here you can cancel above. So that will be xn minus m. Okay, so that's rule 2, if you can write that down, please. You got that? Yeah? Okay. Rule 3. xnm. So we haven't seen this one yet in any question. Do we know what this becomes? Times, yeah. N times n. And the proof? Proof? Well, we could just actually use the definition. Power m means we have m of these, right? This power m is telling us I have m of these. And then what we can do is we can use rule 1, which changes this into plus. And how many pluses do we have here? M of them. So, when you add the same thing many times, it's the same as multiplication. There you go. Okay, so if you can write that one down, that's rule 3. Okay. You got that? Yeah. So the fourth one we'll do, let me see, I think I'll do the negative one. X power minus n, that's equal to 1 over x power n, yeah, like that. The proof, x power minus n equals x power 0 minus n, which equals x power 0 over x power n, which equals 1 over xn. Now, perhaps we better make this kind of clear, so I'll just put that, I'll skip 5 for the moment, just so, no, I'll just write here, C, that was 4, 5, yeah. We'll talk more about this one in the 6th and final rule, but we'll go on to number 5 now, which is x power 1 over n. Yeah. So what's this one? Yeah, well, how do you pronounce this? What's it called? Yeah, but what type of root? Nth root. Nth root of x. Okay, and the proof? We'll put a power n on both sides. So this will be x 1 over n times n, and this is by using, what was that, rule 3. And this is equal to x. And this is just by the definition. You know, if I said to you, what is the square root of x squared, you'll get back x. If I said, what is the cube root of x, then cubed, again, you'll get back x. This will be x power 1, which equals x, and that's obviously true. Right. Okay, rule 6 is more just a couple of clarifications. Can I scroll down? Mm-hmm. Yeah. So, x power 0 will equal 1, provided that x is not 0. 0 power x, that will equal 0. Again, we're not allowed to use x as 0. 1 power x, obviously 1. And any other ones we need to know? Okay. What is this one?
1.
According to which? The first one? Power 0 equals 1. But what about this rule that says 0 to power 0? What do you think? Infinity.
Yeah. I usually put this side.
Not infinity, no. Doesn't exist.
Yeah.
Yeah, undefined.
Like circle, cross.
The nulls, yeah. We would usually just write undefined. No value.
It's okay. Yeah, you want homework.
Well, let's look at some examples now. And lastly, just to put inside this rule, there's a constant that we make use of in this chapter called E. And this constant is on the calculator. So you don't have to worry about knowing its value. It doesn't, it's irrational. It's like pi. It just keeps going. No, that's wrong, sorry. I think isn't it? What does the calculator say? It goes 7, 1. Okay. That's far for the calculator, fine. Well, the next 6, if you need them, are there. You won't need them.
Yeah.
It comes up in logs as well, yeah. It's just a number, it's just a constant, okay? It's a lot like, pi. It just has a constant value, okay? Right, let's have a look at some examples now. So, first example, just to practice using the formulas. Z power 6 cubed, what would that be, simplified? Z power 18, so that's fine. Okay. Now, the next question, of course, you can use your calculator, but in the exam they might want to see the steps. And the other thing about this question is there's more than one path to get to the answer. So there's, what is that? 2, 4 root 16. Can you see that? That's a 5, 5th root, 4th root, 4th root. Now, there's many things you can do first here. For example, you could simplify these two. Yeah? Or you could maybe want to simplify that, or maybe you want to simplify that first.
Everything.
Or everything at once. I'm going to go with first simplifying that, because that seems easy to do first. So 32 over 2 is 16.
32 is 2 to the power of 5.
Yeah, and while we're at it, okay, let's change 32 into 2 power 5. And then while we're also at it, we could change the 16.
4 to the power of 2.
You said that backwards. 2 to the power of 4. Like that. I just changed the 32 into 2 power 5 and the 16 into 2 power 4. Okay? Now, next, I think it's obvious, but if not, we'll use which rule? The 5th rule or something. So you can change this into 2 power 5 power a 5th. And then here, this is 2 power 4 power 1 over 4. And what happens to these powers? Yeah, because they multiply. So 5 times a 5th, it's 1, and you're obviously left with 2, because it's 2 power 1. But you could have seen that at this step too. 4 times a quarter, it's 1. And then 2 over 2.
Multi-explanations.
And then this is 4th root of 16. And 16 is simplified. So the same thing's going to happen, isn't it? So in total, you're left with 2 then. Okay. Now that's fine for this one where you have numbers, okay? Because you could have typed this in on the calculator. But in the next example, we can't do that as easily. All right, write this one down, please.
Looks like a coursework.
No.
Like, there's a lens of explanations.
Well, yes, maybe that, yes. If the exam question said to show all your steps, you'd want to be safe, you know.
Yeah.
I have David. Yeah. Amy? Oh, there. Ray? Oh, there. Priscilla? Oh, right in front of me. Well, nearly. Patrick? Joshua? I have, yeah. Vanessa? Yes. And Umar? Diana? There you are. Mohammed Osman. Okay. Your name has changed, has it? Yeah. So, it looks like I'm only missing Aziz, is it? Yeah? Okay. Right, next example. A little trickier now. Square root z power 5 fifth root z over z squared fifth root z minus 4. Okay, a little harder now. I'm going to give you a minute to try it, similar to the last example, then I'll give you the answer. Let's see if you can do this.
Z to the power of 2, yeah?
Yes. Although z to power z would be more interesting. Nice answer in the end, is it? Got it? Yeah. Now, what I'll do first, I'll say z5 over z squared is z cubed. Yeah. And yeah. And because these are both fifth roots, I can put them as one single fifth root. And this would be z power 1 over z power minus 4. Now, I'm only allowed to do that because they're both fifth roots. This is square root, z cubed, fifth root, z1 over z minus 4 in total? 5, yeah. And then what happens here? This would be square root, z cubed, and then that would be z power 5 power a fifth. Yeah, which is 1. And z cubed by z is 4. And this would be z 4 power a half, which is z squared. Okay? But there are many paths to that answer. Okay, write that one down.
I don't like that. I should do it to X.
Hmm?
Z, like, the large one is too complicated.
It's too complicated.
Yeah, so I'm using X.
I put the line in the middle so it's never confused with a 2. So okay. You got that? Yeah? Okay. Next now. Not a major one. We just want to write these as a sum of x's with powers. So we expand on the top and we get 4x squared, yeah, 4x plus 1. Or to be super clear, that's 4x squared plus 4x1 plus, and what would you change the last fella into as an x power? 0. Yeah. And this is x power 1. So this would be 4x squared over x1 plus 4x1 over x1 plus x0 over x1. So what's the first one? That's 4x. What power? Ah, yeah, well, if I must write in a power, be 1. And then the next one, if I must write in a power, 0. And the last one? Minus 1. Okay, so that's me writing the answer. You know, the exam question might say something like express in the form something like ax with a power plus bx with a power plus cx with a power. So actually what I might do is just write the number 1 here. Something like, you know, some question like this I could see in the exam. Okay, write that one down. We'll talk about graphs next. Yeah? The 1. If it was me doing an exam and I wanted to be safe, I would make sure my answer matches perfectly what they want. You probably don't have to, but better to be safe. Okay, you got that? Yeah? We got that? So we'll just talk a little bit about graphs now. So sometimes in the exam they might ask you to do a quick sketch of a graph like something like of this form. So for example they might say to sketch y equals 2e power 3x. Something like that. Now you could take out your calculator and calculate different values and plot them that way, but what I want to show you is there's really only 4 possible graphs here, and it depends on if the A and the B, if they're positive or negative. So let me just make space here. We'll draw the 4. So the first graph is if the A is positive and the B is positive. Let's make all the 4 possibilities. Okay, so the first graph is if A and B are positive, the graph shape will be like this. And does anybody know what this point on the y-axis is? For this particular one?
X 1.2.
I'm not hearing it yet. No.
0, 0, 1.
No.
Special name for this.
A.
No, 0.8.
A. If x is 0, what's e power 0? 1. And 1 times A? Yes. 1 times A is 1A. Thank you. So yes, A. Is that okay? Are you sure? Because it didn't sound okay. No? Y equals A, E, B, X. X is 0. So Y equals A, E, B times 0, which equals A, E, 0, which equals A times 1. And as Captain Obvious told us, A times 1 is A then. Yes. Is that okay? Yeah. So let's go back here. The next graph I want to have a look at is if one of them is negative. So let's just let's say this time the A is still a positive. Whoops. The A is still a positive, but we'll make the B a negative. So does anybody know how the graph shape changes here? It's going down, yeah. So the graph will be looking like this. Oh, by the way, these graphs don't actually meet the x-axis. Gets close, but doesn't meet. And again, what is this point here? A. Because nothing has changed. You still put in x as 0. Right? Okay. Now, let's look at A is negative and B is positive. What happens here?
Below the graph.
Yeah.
Below the x-axis.
And is it moving away from the x-axis or is it moving towards the x-axis? It's moving away from it still. Yeah, like this. And this point here?
Minus
A. Because I've already said the A is negative.
A. Okay.
Yeah. Okay. A is negative. A is negative and B is negative. So it is moving towards the x-axis and it's upside down. So I think, yeah, we're like this. And now you should see it. Yes, you should see a pattern emerge here. This point here is again A. These are the 4 possibilities here. Okay, if you can add those to your notes, these are the only 4 types of graphs they could have you sketch in the exam. And they do like you to mark off the point on the y-axis. So we'll do one example in a moment. Pretty straightforward. Okay. Not yet? Okay.
No.
That was a very firm no. Okay, we got that? Nearly, it looks like. For those people who have it, what I'm going to do in a moment, if you want to try it, is this one. I just want you to sketch, including the point on the y-axis, y equals minus 4e minus x. You give me a quick sketch of that, and then I'll draw it for you. Whoops. Okay, do you have that drawn?
Yep.
Yeah? So which of the four situations is it? Bottom right, the last one, isn't it? So let's have a quick sketch here. It is, what was it? Y equals minus 4e minus x, isn't it?
Yep.
So it's upside down and moving away. Isn't it? Is it? Oh, sorry, moving close to it, yeah. So it's like this.
This will be minus 4.
And this would be minus 4, yeah. So, that might be in the exam for like, 3 marks, maybe 3-mark question, section A or something. Sketch this. Yeah.
That's everything that we need to show?
There's nothing else to show because it doesn't cross the x-axis. There's no vertex. Yeah. Okay, so you can try some of these and then we'll go on to logs. 1AB, 2AB, 3AB, 4AB, 5AB, and 6AB. Okay, you can get started on those. Just until 10 to, then we'll start the next lesson. No break and we'll finish sooner.
We'll start in 15. 50? We'll start
Yeah.
in 50.
And finish at 40.
I should run, so I don't have no breakfast.
You have no
So
breakfast?
I have like 15 minutes till 12.
Oh, you were counting on having breakfast at about. But if you wait another hour, you can have lunch.
Lunch is too expensive.
Brunch. What's your budget for lunch? Right, you give me a budget, I'll tell you what you can get and where.
I'm usually cooking by myself. budget?
That, yes. The cheapest place to get lunch is, there's a fried chicken takeaway. So, here's the school.
I thought we were doing maths, not
No,
history.
no. Come out of the school, turn right, go to the traffic lights, turn right, and here there's some fried chicken place. They have the cheapest lunches, so you could get like burger, chips, and a drink between €5 and €6, depending on the burger or what it is. So if you're really hungry and you want a lot of food for €6, you can get their kebab meal. Kebab, chips, and a drink. That will fill you up for breakfast and lunch.
Yeah, I need to try.
Yep.
But on the other hand, for €6, I could buy like 1 kilogram of meat,
True.
some potatoes, some like other vegetables. and
Still.
food, like for a few days.
It's a kebab, you know.
Alright.
Kebabs are nice.
You got